Okay, now we're gonna go ahead and start the Unit 1 portion of the final exam study guide. Okay, so Unit 1 is about stoichiometry, and we started the stoichiometry unit with reading the chemical equation. So we learned about the parts of the chemical equation. And then what we're gonna do first is we're gonna label each part. In the chemical equation, you are able to find what are the reactant and what are the product. And reactant and product is divided by the sign, the symbol, the arrow symbol. So the C right here is depicting the yield sign, where the chemical equation is dividing the reactant and product. So the part on the left is considered as a reactant. And the part on the right is considered as a product. Okay. Now we're going to label A, B, C, D, and E. Okay. So my A is a number in front of the chemical formula, which is considered as, we call that one as a coefficient. And the number that behind each atom is called as a subscript. The small number so coefficient is a big number in front, and then subscript is the small number right after the atom. So if you don't see any subscript after an atom like Ag or N, then we assume that there is one. So therefore, you have one atom of Ag, one atom of nitrogen, and three atoms of oxygen in this particular chemical formula. So that's what it means. All right. And then the C, we labeled it as a yield. And after the formula, we put a parenthesis to describe the state of a matter. So if you look at D, you're looking at the state of matter, which is solid inside of the parentheses. So that's how you depict the state of matter of Ag, which is the silver. And the E, which is aqueous, sorry. E is aqueous. So we got the solid and aqueous down. So if you have a gas, then it will have a parenthesis G and close the parenthesis. If something is liquid, then it will be parenthesis L and close the parenthesis. So that's the part of a chemical equation that you're responsible to know. All right. Now we're going to change this chemical equation into a sentence, because you'll be asked to read the chemical equation or convert the sentence into a chemical equation. All right, so the coefficient is always read as a mole. So we're going to start from 2AgNO3 AQ. Hang on. Okay. Yeah, going back to what I was saying, we're going to start with the 2AgNO3 AQ because that's the first chemical that we have on this equation. So 2 mole of, and the state of matter would be stated the next. Aqueous AgNO3, and it's reacting with the copper, a solid copper. That's what we're gonna write. Is reacting with, and then we have to make sure we put how many moles we are reacting it with. So it will be 1 mole of, again, the state of matter, which is solid copper. Now we're at the arrow, so we're gonna write to produce, because we're producing the products. Then we're gonna move on to 2 AgS. 2 means it's a 2 mole of, again, state of matter is a solid, so we'll write solid Ag. And we have another product. And then we have 1 mole of it. So 1 mole of, again, state of matter, which is aqueous. And then we will write the formula, which is CuNO3, 2. So that's how you convert from the chemical equation to a sentence. You may be asked to do the other way, where you are given a sentence and go back into the chemical equation. Just make sure you are putting 3 things per chemical substance. 1, how many moles of it? 2, what is the state of it? And then 3, the correct formula with the subscript. All right. So now we're gonna change the following sentence into a chemical equation. What are the reactants and products? Okay, so this is when we go the reversed. It says 1 mole of N2 gas is reacting with 3 moles of H2 gas and makes 2 mole of NH3 gas. So it gives you all of those 3 things that I asked you to put. Okay, so it will be 1 mole of N2 gas is reacting with 3 moles of H2 gas and makes 2 moles of NH3 gas. So that would be how you convert the sentence into a chemical equation. All right, that was the very first skill. And we're going to move on to the mole ratio. All right, so whenever you're writing a mole ratio, you use the number in front of the chemical formula. So in front, and which is called as a coefficient. It is a coefficient that is in front of a chemical formula. All right, when there is no number in front of the chemical formula, then we assume that there is a 0. Not 0, sorry, there is a 1. It's morning thing, I couldn't. So if there's no number, then we will assume that there is 1 in front, such as this one. If you don't see any number, then we assume there is like 1 and 1 mole. And this one right there can be removed. You don't have to put 1 in front because that's assumption. And whenever we write the chemical formula. All right, so now in the equation below, what is the mole ratio between N2 and H2? It's asking you about the mole ratio. The mole ratios can be written in many different ways, but we can write that into a ratio form or a fraction form. So if we write it in ratio form, then N2 has 1, and then H2 has 3. So it will be 1 N2 to 3 H2. Actually, to be more correct, 1 mole of H2 to 3 mole of H2, like not N2. N2 to 3 moles of H2. If we write in the fraction form, it will be 1 mole of N2 over 3 mole of H2. Or we can always flip the fraction and say 3 mole of H2 over 1 mole of N2. Right. So that is how you can write the mole ratio in fraction form. All right, now we're gonna move on to skill number 1.3, which is using the mole ratio. So the reason why we write out the mole ratio is because we want to be able to convert between mole of one chemicals to mole of the other chemical. All right, so 1.3, mole ratios are used when the given and what we're looking for have different chemicals. Given is in so unit 4 given would be mole, and we're looking for mole of A, and then we're looking for mole of B when those are different. Okay, so in the following reaction, N2 plus 3H2 equals to 2 NH3. How many moles of H2 will be needed to make 1.36 mole of NH3? So how you use the mole ratio is you will set up a conversion factor, which is called the mole ratio, and then use it with the given. Okay, so the mole ratio between whenever you see this question, what you want to do is you want to write a mole ratio between H2 and NH3. So let's write that out. H2 is 3 moles of H2 over, that's 2 mole of NH3. So 2 mole of NH3, or it can be 2 mole of NH3 over 3 mole of H2. So we're gonna use either of these, like one of these. All right, so our given is 1.36 mole of NH3. So 1.36 mole of NH3. And if you recall the algebra, we can cancel the top and the bottom if the unit is the same. So what we're gonna do is we're gonna bring our unit, this unit, to the bottom side, which mole of NH3, and then look at our examples of mole ratio. And then the top one, this one, has the mole of NH3 on the bottom. So that's what we're gonna use. So 2 mole of NH3, and then the top will be 3 mole of H2. So therefore, if I calculate that one out, 1.36 times 3 divided by 2, it will give you, where did I, okay, here. So 1.36 times 3 divided by 2 will give you 2.04 mole of H2. Okay, again, I'll show you which ones are going to be canceled. No. So there we go. So because the mole of NH3 and mole of NH3 is going to get canceled, the only unit that is being left over would be mole of H2. So that's why our unit over here is going to be mole of H2. And the calculation is, again, it will be 1.36 times 2 divided by 2. So that will be the final answer. Okay. All right, now we're going to move on to the calculation of a molar mass. Okay, molar mass is, wow, now people are coming. Well, good. All right, so let's move on to the molar mass. So molar mass is a mass of an element or a compound per 1 mole of that substance. It can be an element or compound. So the unit for the molar mass is, let me go and write that. Oh, sorry. Unit is going to be grams per mole. So for example, before I move on to example, let's fill in the blank for the very first sentence. So molar mass of a single element can be found from the periodic table. So whenever you see molar mass, then what you need to look at is the periodic table. So in the periodic table, the number that you need to look at is not the top number. Top number is considered as atomic number. You have to look at the average atomic mass or the mass number, because that is the mass of one single element per 1 mole. Okay. And the second part, whenever you have a compound and you want to determine the molar mass of a compound, compound is like when you have more than one element. It can be determined by adding up all the molar masses. Adding up all the molar masses of every element in the formula. So that's what we'll do when we are going through this molar masses. All right, so the very first one that we're gonna do is C3H8. Okay, so I kind of memorized the carbon and hydrogen, but you should look up what is the molar mass for carbon and hydrogen and then add them up. So carbon, if I look at the periodic table, it's 12.01 grams per mole. Hydrogen is 1.01 grams per mole. Oxygen is 16.00 grams per mole. Yeah, and then we'll just figure it out as we go. So C3H8, what we want to do first is we want to list how many carbon you have. So carbon, you have 3. Hydrogen, you have 8. So we're gonna just multiply each number by its molar mass. So 3 times 12.01, hydrogen will be 1.01. Okay. Okay, 36.03 and then, right, correct. So if I add those two, yeah, good job. So it will be 44.11 grams per mole. All right, let's do the CO2. So we have one carbon, and then oxygen will be two. We do the same. Oxygen will be 16.00. So if we add them up, then it will be 44.01. Yep. All right, so that will be CO2. Now we're gonna do NaNO3. This one we have three different elements. Okay, so sodium Na would be, I have one, and three. It will be 22.99. Nitrogen is 14.01. Oxygen is 16.00. I think that's right. Yep, so 22.99 plus 14.01 plus 48 would equal to 85.00 grams per mole. So it will be 85.00. Somehow it becomes a whole number. All right, now the last example is something that I want you to pay attention a little bit more. So this one we know that we have two aluminum, sulfur, and oxygen. When you look at this one, I'm just gonna enlarge this to emphasize. When you do this one, make sure you are multiplying 3 times 1 and then 3 times 4 to get each one of them. So sulfur is actually, you have 3 of them, and then oxygen you have 12. So aluminum is, okay, thank you. And then sulfur would be, okay, and then oxygen would be 16. So if I actually need to multiply those. So 2 times 26.98 is, and then 3 times 30.07 would be 96.21. 12 times 16 would be 192. And then if I add all of that, yeah, I got 342 and 17 grams per mole. All right, so that was the molar mass calculation. So let me put a square around the correct answers. That's the answer. That's the answer. Here's the answer. That's the answer. All right, so I hope that was simple enough. Now we're gonna move on to the conversions with the molar mass. All right, so molar mass is used to convert between moles and grams of the, it will be the same. What happened? Okay, same substance. It will be the same substance. If you have a different substance, then you will have to convert the moles to, or grams to mole, and then use the mole ratio to have the same given and looking for substance. All right, I can talk about it later. when we get to it. Okay, so it says how many moles of Al2SO43 are in 450 grams of Al2SO43. So we already calculated the molar mass of it. So I'm going to use that. So your step 1 would be calculating the molar mass of your given. Which is already done. And then step 2 is you will multiply given. No, not multiply. You will divide given by the molar mass. Or you can see it like 450 grams of Al2 SO4 3 times grams of Al2 SO4 3. Now this gram is 342.17. And then on the top, it will be 1 mole of Al2 SO4 3. But it will be the same thing as like 450 divided by 342. Let's do it. So 450 divided by 342.17. It will be 1.3. I have 1.315 on my calculator, but what you will report the answer as would be 1.32. And then the unit would be mole of Al2 SO4 3. Okay, so things to note is that the grams of Al2 SO4 3 will be canceled. So the only thing that is left would be moles. So this will be your final answer. Okay. Question 2, it says how many grams of CuNO3 2 are in 2.81 moles of CuNO3 2. Okay, again, we're going to calculate the molar mass of the given. We know that our given is CuNO3. Let me change the color. So we're going to follow each step. Step 1, calculate the molar mass of given. Okay, so Cu is 1. 1 times 63.55. And N you have 2 times 14.01. Oxygen, you have 6 of them. So it'll be 96.00. Hang on, let me put some more space. Okay, so it will be 63.55 plus 28.02 plus 96.6. So my molar mass would be 187.57 grams per mole. And step 2, what you will do is you will multiply given by your molar mass. That is done by this process where you have 2.81 moles of CuNO3, 2 times, we're always going to bring the unit on the bottom, so mole of CuNO3, 2. And then the top will be grams of CuNO3, 2. And the grams would be 187.57 and the mole would be 1. So if I do that, I will get 527.07 grams of CuNO3, 2. Then that will be, that'll be my final answer. Then I just want to make sure that you know that this part, that part will get canceled. All right, so that was 1.5. We need to go over 1.6 and 1.7. And that's where we're gonna stop. Okay, I'll leave this up here for you to kind of finish writing. All right, so now we are gonna merge these two skills, converting with the molar mass and converting with the mole ratio. All right, so it says conversion with the molar mass and mole ratio. It says if we want to convert between moles of one substance to the mass of another, then both the molar mass and the mole ratio should be used. And that's because we're not converting it between one unit of the, like the same unit, which is mole to mole of the different substance, or we're going from this different unit, grams to mole or moles to gram within the same substance. All right, so the important thing for these questions would be like identifying what your givens are. All right, I feel like I'm gonna need some more space. So I'm going to add more space. So give me a few seconds. All right, so question number 1 says, question 1 in this section says, in the following reaction, N2 gas reacting with the 3 moles of H2 gas will make 2 moles of NH3 gas. How many grams of H2 will be needed to make 1.36 mole of NH3? So it says grams of H2, that's what we're looking for, and then 1.36 mole of NH3 is what we have. So our given is 1.36 mole of NH3. And we're looking for H2. But we are looking for the mass of grams of H2. All right, so what we'll do first is we will write we will calculate the molar mass of your looking for, because that's what the gram is, and then we're gonna write the mole ratio. So step 1, calculate the molar mass of both. So H2 would be 2.02 grams per mole, and NH3 would be it will be 14.01 plus 3.03 which is equal to 17.04. All right. And then step 2. Write the mole ratio where you're given is on the bottom and then looking for is on the top. So it would be our given is NH3. So NH3 has 2 moles. That's 2 moles of NH3 on the bottom. And then H2 has 3. So 3 moles of H2 on the top. And then step 3, what you'll do is a given times the mole ratio times the molar mass of looking for. And this is how it's done. So our given is 1.36 mole of NH3 times the mole ratio, 3 mole of H2, and then 2 moles of NH3 times the molar mass, which is H2, so 2.02 grams of H2 over 1 mole of H2. So that will eventually cancel out the mole of NH3 on top and bottom, mole of H2 on top and bottom. So the last unit that you will see will be grams of H2. So let me calculate that. 1.36 times 3 divided by 2 times 2.02 will be 4.12 grams of H2. Let me double check. 1.36 times 3 divided by 2 times 2.02. Yes, that's correct. So your final answer for this particular question would be 4.12 grams. Right? It looks like a long process, but when you follow through the steps, it's okay. It's doable. All right, question 2, we're gonna move on to question 2. The step, so they're gonna be a little bit different. For this one. Okay. So we know our given is right here. So 40.21 grams of NH3. Looking for is moles of H2. So what the difference between question 1 versus question 2 is question 1, your given is in mole of one substance. Question 2, your given is in grams of one substance. Question 1, you're looking for is in grams of the other substance. Question 2, you're looking for is mole of the other substance. All right, so we're gonna just follow through each step. So step 1, calculate the molar mass. But we already calculated them on the top, so I'm just gonna use that. So H2 is going to be 2.02, and then H3 would be 17.04 grams per mole. Step 2, is write the mole ratio where your given is on the bottom and then looking for is on the top. So our mole ratio would be 2 mole of NH3 over, no, it's not over. And then on the top will be the H2, so it will be 3 mole of H2. Okay. Now I need more space, okay. Off focus. No. All right. Going back to what it was, okay. So our step 3 would be given divided by the molar mass of given and then time it by mole ratio. And this is how it's done. So your given was 40.21 grams of NH3. We will write the molar mass ratio. So NH3 has 17.04 grams over 1 mole of NH3 times the mole ratio, which will be 3 mole of H2 over 2 mole of NH3. That will get you the answer. So 40.21 times 1 divided by 17.04 times 3 divided by 2 will be 3.54 mole of H2. Okay. So that will be your final answer for the question. Let me write out how things are getting canceled. Grams of NH3, moles of NH3, and then the final unit will be mole of H2. All right, so that's how you would solve the conversions with the molar mass and mole ratio. Here we go. Hi. Check it. Because here is the study guide before the 500. It's small, but it may be helpful. Well, if you want to staple it, you can staple. If you don't want to. All right. I know it's long, but we need to continue. All right, so the last thing that we have left for the first part of the unit 1 is conversion from mass A to mass B. This one is going to be a little bit longer than the previous one, but we can do it. All right, so when we're converting from mass of one substance to mass of another substance, we have to calculate the molar mass of both. Both. Come on, stop moving like that. Both substance and the mole ratio. Okay, so step 1, before writing step 1, we're going to write the given. So our given is 40.21 grams of NH3. Okay, and our looking for is grams of H2. Okay. So it's actually extending one more step from the question 2, but we'll follow through each step. So step 1, calculate the molar mass of each one. So NH3, we calculated before, so I'm just going to use that. 17.04 grams per mole. H2 would be 2.02 grams per mole. Step 2, write the mole ratio we're looking for is on top and given is on the bottom. Okay, so it'll be like mole of H2 is on top and then mole of NH2, NH3 is on the bottom. Now we get these number, NH3 has 2 and then H2 has 3, so that will be our correct mole ratio. Step 3, it will be given divided by the molar mass of given times the mole ratio times the molar mass of looking for. Okay, it's gonna be a little longer. So 40.21 grams of NH3 times 1 mole of NH3 over 17.04 grams of NH3 times the mole ratio, which is going to be 3 mole of H2 over 2 mole of NH3 times our molar mass of looking for, which is going to be 2.02. So 2.02 grams of H2 over 1 mole of H2. And that's going to equal to, let's see, 40.21 times 1 divided by 17.04 times 3 divided by 2 times 2.02 divided by 1 will give you 7.15 grams of H2. All right. Let me go through which one is going to get canceled. So grams of NH3, grams of NH3, mole of NH3, mole of NH3, mole of H2, mole of H2, and then finally you get grams of H2 that is being left over, the unit, and this 7.15 grams of H2 will be the final answer. All right, so I'm gonna stop here for the part 1 of unit 1. And then I'm gonna do the part 2 of unit 1 later today. So you can watch the video. Oh my God, I thought the Zoom got stopped, but okay, good, it's not. Let's start recording.